So a few weeks ago, Google has released a model called Gemma. It's from their DeepMind team. And from what the document said, it's based on the architecture and the technology that is similar to the Gemini model that they have released before. Now, this model are available in two sizes, 2 billion parameters and 7 billion parameters. And both of these sizes have two versions, the pre-trained version and the instruction tuned version. Now, according to its website, these models are supposed to be best in class performing compared to the model of similar size and also open models as well. And what is exciting, and I want to test it out, is that it should be able to run on a laptop. In terms of performance, how is it compared to all other open source models? In this chart given by Google's white paper, it's comparing Gemma with models, open models like Llama 2 and Mistral model, like 7 billion parameters, across 4 domains of task. The first one is question answering. The second one is reasoning. The third one is about math and science. And the last one is coding. So Gemma is in the green boxes here, while the other models are in other colors, so like so. And the y-axis is actually the score for the performance. So it seems like with the Gemma 7 billion parameters, this model can compete with Llama 2 and Mistral 7 billion parameters, especially it's winning in math and science and coding. So this is very exciting. If it's open source and you are needing the model to do custom tuning to fit your business in the tasks that are like related to question answering, reasoning, or even solving some maths, probably basic maths, and also coding. So this Gemma model could be the one that you need to borrow and fine tune it for your applications. So the model is now available on Hugging Face and Kaggle. Here, this is Hugging Face website. You can search in the box for Google's model, especially you can specify that it's a Gemma model that you are looking into. So let's actually go and use it. So I am in my web browser now. I'm actually in Kaggle website. This is the Gemma model from Google, and you can see that people have started using it. These are some notebooks that you can take a look. So for example, one of them, I actually clicked this one, Gemma meets LangChain, summarize Kaggle rise up. So this is what people have tried before. For those of you who are adept to programming, you can actually take a look at how this notebook is all about. This is like import the model, run Gemma directly. Like that, you give it a maximum length. This is like 256 tokens that the Gemma model will generate. It takes about 12 seconds here. LangChain is a library that helps structuring and providing tools to use the LLM. And this is something that I will be talking specifically in the future. This is Hugging Face, a website that I was talking about. You can you can search for Google models here, and you will find Gemma and other models like this, like the Flat and T5 models. So as I mentioned, Gemma has two versions, right? The 7 billion parameters and the 2 billion parameters, but also two varieties of training. The IT, this one means instruction fine tuning. So you are supposed to use these models if you are using it for conversational purposes like a chatbot. The base model or the pre-trained models, actually it's recommended for you not to use it directly. You need to take the model and fine tune it later for example, using like supervised fine-tuning or instruction fine-tuning. What I'm interested here is, can I just use it right now? It's supposed to be open, right? Open source, right? So what it turns out is that I can. But if this is the first time that you are doing this, you need to sign up, create an account with Hugging Face, come in here to this model and request for access. I have done this myself, so this I have got my access to this model. But if this is your first time, you need to do this step. It's easy. You just click a button. You're supposed to read some terms and conditions first too, and then click the button. But after that, now you have the access to. All right, so what is this thing? This is a page called the model card. It's supposed to contain all the information that you need to know before you use the model in your application. So, okay, I'm going to read through this. This model responds to the 2 billion instruct version of the Gemma model, as I mentioned. Again, it's signified here with the int at the end of the model name, model version. Also, Gemma, one of the highlights that Google advertised when they released Gemma model is their responsible generative AI toolkit. This is, I guess this is a work in progress, because a few weeks ago, as you probably have known, some of you might have known this, their text-to-image generation model has created some undesirable images that inaccurately depicting historical events. I don't want to go into the detail like this, but this is in the scope of making AIs that are responsible in a sense that it's ethical. It reduced the bias, like racial, sexist bias from the model. And seems like Google is fixing what it had done, but I'm sure that in the end, Google will be able to achieve that. Let's continue. These are the terms of use. You can read it here. Now, this is the description. So as I mentioned earlier, this is based on the Gemini technology. It's a text-to-text, so pretty much a large language model. It cannot create images right off the bat. In terms of the usage, this is in Python, I think. Not I think, I'm sure this is in Python. Now, in this model card, it provides you with instructions how to use the model in CPU setup or GPU setup as well. This one is about using the model in full precision. We will be talking a little bit about this in the next section. But now you can run these models in full precision or quantized bits, quantized models, so that you reduce the size of the RAM or the memory that you need. So yeah, you can follow these instructions in order to try to use the models. So what I will be doing here is I would like to run the model on a CPU. The reason I'm doing this is that I want to show you how to use Colab. Colab is a tool that allows you to run Jupyter Notebook on Google's infrastructure, and it turns out to be free most of the time. So the way it works is that you go to Google Colab. It was supposed to be, so the file will be saved in your Google Drive, but you can search for Google Colab. You can sign up and start using the notebook again. So Colab is a hosted Jupyter Notebook service that will be run on Google's infrastructure, and the file or the notebook itself will be saved to your Google Drive. So there are resources that you can. Here, you can change the runtime type. You can choose to run on CPU, GPU, or even TPU, right? But there might be costs associated with running GPU and TPU. So I would like to stick with the CPU for now because it's free. So I can choose that, okay, I'm running CPU. I will be using Python 3 rather than R. and then I'll save it. So then I need to connect to a new runtime. So what is this doing is actually going to communicate with the Google infrastructure, asking for compute resources, for example, the memory like RAM, and the GPU, the disk like this. So you can see that these are the resources that I get from a free version. But if you need more memory and disk space, you can upgrade to Colab Pro. It will be some cost for sure. But what I want to try is whether I can just use this library for free, right? Using GPU and Colabs. It will take some time. So what it's doing is I run this cell. Now Google Colab has this. Oh, I need this. Title: Gemma CPU doesn't have access to the secret name. Grant access. I do need to grant access. Okay, what's happening behind the scene is I'm downloading this model from Hugging Face, and in order to do that, I might need some tokens or access tokens. Actually, link my application on Colab to my profile on Hugging Face, and this is done by coming here to the setting in your Hugging Face and create some tokens or message or key, and then provide it to Google Colab to do so like this. This is my Hugging Face token. I provide it here so it can now Colab program can use this token, verify my identity to Hugging Face and download the model. You see that it's been a while. It's not done yet. So what it's doing is that it's downloading tokenizer, one of the components that we need to process human language into the numeric language that the model understands. I will have a course about this for sure, so that we provide a basic background to people who want to know it in detail, but not going to be doing that at the moment. So now it has download and initialize the tokenizer. In this one is downloading the model. So this model is almost like 5 gigabytes already, and you can see that now it's used up my system RAMs, the almost 12 gigabytes. Luckily it's not full yet, so I can still run this. So I want to ask the model, what is the capital of Thailand? This is a human language, right? This is called input text. Input text will be given to the tokenizer, which is going to tokenize this sentence. What I want to show you here is this is the numeric representation or the token representation of a human language. What is the capital of Thailand? We will feed this to the model. The model is this Gemma 2 billion parameter fine-tuned in the instruction fine-tuning manner. And okay, maximum length, I want to change it to 56, as we saw in the Kaggle example previously. Alright, so I am giving this numeric representation, or the token representation of my human language text to the model, and this will cause the model to generate the response. This will take a while because I'm running this on GPU, and there are so many computations happening for the model. The model is providing words in sequence, right? So large language model is what? It's the model that predicts one word at a time, given the context that's come before. So this is happening. It's like predicting words by words. So, and also because I'm computing it on a CPU, it will need some time. Let's see. In this Kaggle example, it takes about 12 seconds to finish computation. It's coming up, guys. In my previous videos, we saw that when I was using Gemini, or ChatGPT, the response time was about a few seconds, like 3 seconds or 4 seconds, much faster than this. This is probably because, not probably, most likely because they have fast infrastructure for computation. Oh, okay, it's done. The output is computed. What does it look like? Well, the output from the model itself is numerically gibberish for now. What we need to do is we need to use the tokenizer to convert the numeric language that the model understands back to our human language. Here comes. This is the output. The output seems to repeat my questions, but it has something appended to it. It's the answer from the Gemma model. Gemma says, the capital of Thailand is Bangkok. It is the largest city in the country, and it is, and also the political, economic, and cultural center of Thailand. I think this is bang on. Pretty good. So I think with this example, you can actually have your hand on Gemma 2 billion parameter model and start using it. You don't need to pay ChatGPT for this service anymore. I think you can try using it yourself. One of the drawbacks of using it this way is it's very slow. But if you wanted to use GPU, you can buy more credits to use GPU on Colab as well. Thank you very much for watching our video. If you like it, leave a comment. And don't forget to subscribe to our channel, Case Done by AI, and see you at our next video.